Hello, fellow commercial ground students. My name is Andrew Mills, and this is discussion board 1, the base to final turn. The base to final turn, if flown incorrectly, can pose a significant danger. It is inherently dangerous due to an aircraft's low altitude during this maneuver. The consequences of a stall at this altitude are often fatal due to an aircraft's inability to recover before impacting the ground. This is why it's critical to know the common causes of stalls in this maneuver and how to prevent them. As is the case in all other portions of flight, an aircraft turning base to final will stall if its critical angle of attack is exceeded. In base to final accidents, this normally occurs in one of two ways. The aircraft either enters a accelerated stall or a cross-control stall. The reason the aircraft is usually placed into one of these stall conditions is due to a pilot overshooting the extended center line of the runway when turning to final. First, I'll discuss the accelerated stall. The Airplane Flying Handbook states that an airplane consistently stalls at the same indicated airspeed provided the airplane is at a positive 1g, which is steady state unaccelerated flight. However, the airplane can also stall at a higher indicated airspeed when the airplane is subject to an acceleration greater than plus 1g. Consequently, a pilot that overshoots the runway center line when turning to final might be inclined to increase the bank angle and increase back pressure on the elevator controls to tighten the turn. However, this greatly increases the aircraft's angle of attack while lowering the critical angle of attack. Eventually, if you bank the airplane enough and pull back enough, the aircraft will stall. Now I'll talk about the cross-control stall. A cross-control stall occurs when the critical angle of attack is exceeded with aileron pressure applied in one direction and rudder pressure applied in the opposite direction, which causes uncoordination. In the case of a pilot overshooting the turn base to final, the pilot may initially increase the bank angle, attempting to align the nose of the airplane using the rudder. However, this produces a differential in lift between the inside and the outside wings, causing an unwanted increase in bank angle and a pitching down of the airplane nose. The pilot then might attempt to correct this by moving the ailerons in the opposite direction of the bank and applying back pressure to the elevator controls. Unfortunately, the airplane is greatly uncoordinated, and in this position it is perfectly set up for a rapid entry into a spin if the critical angle of attack is exceeded on the inside wing. As I mentioned earlier, the repercussions for stalling at this altitude are very likely to be deadly, so the best option for a pilot who overshoots the turn base to final is to simply go around rather than attempting to save the approach. Another thing a pilot could practice is limiting themselves to 30 degrees of bank in the traffic pattern. At the end of the day, though, the go-around is always the safest remedy to this situation. This concludes my discussion, and I'm looking forward to hearing everyone else's comments.